Hello everyone, welcome back to my YouTube channel. I hope you all are doing well and I hope you all are having a good day. I, J. Yashish, bearing the USN 1VE21CS064, I'm here today to talk about the subject Design and Analysis for Algorithms, which bears the subject code 21CS42. So let's get into the video. The topic I am going to be discussing today is going to be dealing with merge sort, and the following topics would be introduction to the merge sort, algorithm for merge sort, time complexity and its cases, the advantages and disadvantages of merge sort, and the applications for merge sort. Moving on to the first slide, we have the introduction to merge sort. So merge sort is defined as a sorting algorithm that works by dividing an array into smaller subarrays and sorting each subarray, then merging the sorted subarray back together to form the final sorted array. So, in simple terms, we can say that the process of merge sort is to divide the array into two halves, sort each half, and then merge the sorted half back together. This process is repeated until the entire array is sorted. So this is a recursive function which occurs, which is going to be helpful in sorting the given array by using the algorithm merge sort. Moving on to the next slide, we have the algorithm for merge sort. So the algorithm for merge sort is as follows. So algorithm merge sort is going to have an array input from 0 to n minus 1 of orderable elements, where n is going to be the size of the array, and output is going to be an array A from 0 to n minus 1 of orderable elements. If n is going to be greater than 1, that is if the size of the array is going to be greater than 1, then you're going to copy the contents of array A from 0 to n by 2 to array B, which is also from 0 to n by 2. Again, the same function is repeated where you copy the contents of array A from n by 2 plus 1 to n minus 1 to C array, that is from 0 to n by 2. Then you call the merge sort function twice by using the arrays B from 0 to n by 2 and also C from 0 to n by 2. And then another function is called, which is called as merge, which calls B, C and A all together. And this is going to be an end of the first if loop. The second portion of the algorithm is as follows. At first you have algorithm merge, which is going to have the three arrays B, C and A having the components B from 0 to P minus 1, C from 0 to Q minus 1, and array A from 0 to P plus Q minus 1. Here an input is going to be a sorted array B and C, while the output is going to be the merged combination of both B and C, which is going to be stored in array A. Here, the first initializations done are I, J and K, which are all going to be initialized to 0, and the following is going to be a while loop where while I is going to be lesser than P and J is going to be lesser than Q. If B of I is going to be lesser than C of J, then it moves into the if portion of the loop. That is, A of K is going to be initialized to B of I, and the I value is going to be incremented by 1. Or the else portion is going to be executed where A of K is going to be initialized to C of J, and J is going to give me J plus 1. This is going to be an end of an if loop and followed by an increment to the K value, that is K is going to be K plus 1. Next is going to be the end of a while loop, and here another if loop is being given where if I is lesser than P, you copy the content of B from I to P minus 1 to A from K to P plus Q minus 1. Else, you copy the content of array C, that is from J to Q minus 1 to array A from K to P plus Q minus 1. So this is the end of this if loop. So this is going to be the algorithm for merge sort. Moving on to the next slide, we have the time complexity for merge sort. So complexity analysis of merge sort. Merge sort repeatedly divides the given array into two equal sized parts. Thus, merge sort time complexity always depends on the number of division stages. The number of division stages is log 2 to the base n. On each and every merge stage, n elements are merged. Step 1 is n into 1. Step 2 would be n by 2 into 4, and step 3 would be n by 4 into 4, and so on. Each and every time it is incremented by values of 2 and n is going to be divided by values of 2, and here n is going to represent the size of the array. Merge sort time complexity itself is calculated using time per division stage. Since the merge process has linear time complexity for n elements, there will be n cross log 2 base n divisions and merge stages. Hence, regardless of the arrangement, the time complexity of merge sort is O stands for order n log n. Moving on to the next slide, we have the merge sort and its cases. The merge sort cases are divided into three. That is the best case, the average case, and the worst case. The best case time complexity of merge sort is as follows. So the best case scenario occurs when the elements are sorted in an ascending order. If two sorted arrays of size n need to be merged, then the minimum number of comparisons will always be n. This happens when all the elements of the first array are lesser than the elements of the second array. So the best case time complexity of merge sort is order O from n into log n. Next one would be the average case time complexity of merge sort. So the average case scenario occurs when the elements are jumbled. That is, they are neither in an ascending order nor are they in a descending order. So this depends on the number of comparisons each and every time, because this is a recursive function. The average case time complexity of merge sort is again big order O from n into log n. Next would be the worst case time complexity of merge sort. So, the worst case scenario occurs when the given array is sorted in descending order, leading to the maximum number of comparisons. In this case, for two sorted arrays of size n, the minimum number of comparisons will always be 2 into n. So the worst case time complexity of merge sort is again big order O from n into log n. So these three are going to be the best, the average, as well as the worst time complexity of merge sort. Moving on to the next slide, we have the advantages and the disadvantages of merge sort. So the advantages of merge sort are as follows. Stability. Merge sort is a stable sorting algorithm, which means it maintains the relative order of equal elements in the input array. Guaranteed worst case performance. Merge sort has a worst case time complexity of big order O n log n, which means it performs well even on the largest of data sets. Next is going to be parallelizable. Merge sort is a naturally parallelizable algorithm, which means it can be easily parallelized to take advantages of multiple processes or threads. Next one would be the disadvantages of merge sort. First one being space complexity. Merge sort requires additional memory to store the merged subarray during the sorting process. The next point would be not in place. Merge sort is a not in place sorting algorithm, which means it requires additional memory to store the sorted data. This can be a disadvantage in applications where memory usage is a real concern. The next point would be not always optional for smaller datasets. For smaller datasets, merge sort has a higher time complexity than some other sorting algorithms, such as insertion sort. This can result in slow performance for more values or more smaller datasets. Moving on to the next slide, we have the applications for merge sort. Applications. So merge sort is useful for sorting linked lists in order from n log n time. Merge sort can be implemented without extra space for linked lists. Merge sort is used for counting the inversions in a list. And lastly, we have merge sort being used in external sorting. So these are going to be the following applications for merge sort. I hope you understood what merge sort is, the algorithm for merge sort, the applications, the advantages, disadvantages for a merge sort, and the following topics which were dealt regarding merge sort. Thank you for watching the video.